Variance is a very important measure of data spread or variability. Variance shows how far each value in the list is from the mean value. So if the variance is small, then it means that the spread is less in your data, while high variance represents large spread. If you are interested in the actual calculation, then it is very straightforward. You take the difference of each value from the mean, and then you square the difference and then sum for all the values in the list, and finally we divide the whole sum by the number of elements in the list. So as you can see, we have the mean in the calculation, which in itself gets affected by extreme values. That's why variance can also be affected by extreme values. But there is one more issue with variance. That is regarding the unit of the variance value. So as you can see in the formula, we are taking the square of the difference and then summing it up. That's why the unit of variance is basically the square of the unit of measurement. So if we have the passenger age values, then the variance will be in terms of square age, which is not very clear and intuitive. So in order to solve this issue, we take help of another dispersion measure, that is standard deviation. In fact, standard deviation is nothing but the square root value of variance. So by taking the square root, the unit of standard deviation becomes the same as the unit of the feature. Other than the unit of the standard deviation, rest of the concepts are very similar to that of variance. Means, low standard deviation is a signal of less spread in the data, and high standard deviation is a signal of large spread in the data. So now you have a basic understanding of different summary statistics for numerical features. Let's put all of the concepts that we have learned so far in the practical use using the Titanic dataset. In this clip, you will learn to use pandas and NumPy to get summary statistics on the Titanic dataset. Here we are in the Jupyter Notebook. The first pandas method that we will talk about here is the describe function. This is a very handy function to get summary statistics very quickly. So, to get various summary statistics, we can apply the describe function on a data frame object. By default, it will return different summary statistics for all the numerical features. So let's execute this cell to see the results. So we have different types of summary statistics for all of the numerical features in the dataset. So we have mean value here, which is the centrality measure. So we can see the mean age is roughly 30 and the mean fare is roughly 33. If you look at the mean survived value, it is some negative value, which doesn't make sense. But we are getting the negative value because we had set the survived value for the test dataset as -888, if you recall. And that's why we are getting some weird number here. So don't worry about it. Other than the mean, we also have maximum and minimum values with us. So the maximum age in the Titanic dataset is 80 years, while the minimum is 0.17. Well, probably the passenger is an infant. We also have important percentile values here. But as you can see, we have got few nan or not a number here for age and fare features. This is because these features have missing values. Later we can see how we can rectify this issue. Well, other than percentiles, we also have standard deviation here, that is a measure of data dispersion or spread. But overall, you can see the describe function is a very handy function to get various summary statistics in one go. Now let's see how you can get different summary statistics manually. Let's start with a numerical feature, that is passenger fare. To get the centrality measures such as mean or median, you can directly apply the mean or median function available in pandas. So first we extract the passenger fare using df.fare and then apply the function. Remember, by default, pandas will skip missing values while calculating these numbers. So let's execute this cell now. And here we have mean fare and median fare. Now let's see few dispersion measures starting from range. So for range, we can simply take the difference between the maximum and minimum values, and that you can get using the max and min function of pandas. For percentiles, you can use the quantile function available in pandas. And then you can pass the percentile point. So if you pass 0.25, it will give you 25 percentile value. Similarly, you can get 50 percentile and 75 percentile. However, remember, if you have missing values in your data, then pandas will return nan. And as we know that we have missing values in the passenger fare, so you should get nan. Don't worry, later we will fix this issue. For other dispersion measures such as variance and standard deviation, you can use the VAR and STD function of pandas. Now let's run this cell to get results of different dispersion measures. So here we have the result. So fare range is 512. Percentiles are nan as expected. Variance in the fare is 2678 and standard deviation is 51, which is quite high. So as you can see, we have large spread in the passenger fare. Now let's create a box plot to understand the spread of data visually. So in order to create a box plot, you can use the plot function available in pandas. So in the plot function, we can set the type as box in order to get the box plot. So here we are trying to create the box plot on the passenger fare. So let's execute this cell. However, you cannot see the visualization here. This is because we have not told this Jupyter Notebook to render the visualization in the Jupyter Notebook itself. So to fix this issue, we can include one magic function that we have discussed previously, that is Matplotlib inline. So let's include that. So I have created one cell and have used the Matplotlib magic function. So now we should see the box plot here. Let's execute it once again. So here we have our box plot. So this middle line represents the 50th percentile or the median value, and the box is extended from 25th percentile to 75th percentile. We also have quite a few outliers or extreme passenger fare values. Well, so far we have discussed about numerical features. Let's turn our attention towards categorical features.